Let's take a look at a few questions from the June 2014 Algebra Regents. I notice this says the product of 6x to the third, y to the third, and 2x to the second, y is what? Well, I know that when I'm looking at this problem, a few things. One, that we're going to be doing multiplication because it says product, and we're going to be multiplying. And I know that when we're looking at these two terms, we're going to be multiplying the coefficients and adding the exponents because that's the rule. So when I'm looking at it, I can see we've got a 6 and we've got a 2. And so 6 times 2 equals 12. So I know that 12 is the coefficient. And because I know 12 is a coefficient right off the bat, I can eliminate number 1 and number 2 because this is 3 and this is 8 and those are no good. So we're left with options 3 and 4. So now let's add these coefficients. I'm looking at the x's, right? Because we got to make sure that the bases are the same, and this is to the third, and this is to the second. And so I'm going to do x to the third plus 2, and that's going to give us x to the fifth. And then I see y to the third plus 1, right? Because there's nothing there, we can just do a little invisible 1. And that's going to give us y to the fourth. And is that an option? Yep. I'm looking right here. X to the fifth, right? Y to the fourth. This is, I'm going to put these together. This is option number 3. Number 3 is the answer. Let's take a look at number 2. It says, which set of data is qualitative? So in order to get this question correct, you needed to know what qualitative means and the difference between qualitative and quantitative. So quantitative has to do with numbers. Qualitative, on the other hand, has to do with like not numbers or sort of like descriptions. So let's look at our options, and I can see that we've got laps swum in a race, numbers of swimmers on the team, swimmers' favorite swimsuit colors, and temperature in Fahrenheit of the water. So temperature has to do with numbers. I see laps swum is numbers, you're counting the number of laps, and number of swimmers on the team has to do with numbers. Options 1, 2, and 4 are all quantitative. They're all quantitative. A swimmer's favorite swimsuit color, on the other hand, is sort of a description. It's an adjective. It is not defined by numbers because this could be any number of things. It could be blue, green, yellow. There's nothing here that suggests numbers. Number 3, option 3 is the correct answer. It's in number 2. Let's take a look at number 8. It says, an example of an algebraic expression is what? So here we've got a number of items. One of these, however, is different. The key word I'm looking for is equation. So which here is an equation, or which has an equal sign? There's only one here that has an equal sign, and that's option number 3. And I know that because I see the equal sign right there. Option number 3 is the correct answer. Let's take a look at number 12. It says, what is the value of the expression 3 to the second minus 4 times the absolute value of a plus 6 when a equals negative 3. So let's zoom in on this so you can analyze it a little bit better. So I know that we've got this variable, a, right? And a equals negative 3. So what I'm going to be doing is I'm going to be plugging it in here and here. And so let's start doing that. So I'm going to do 3, open parentheses, 2 minus 4, absolute value, plus 6. And then I'm going to simply put in negative 3, negative 3. We're going to do order of operations, and we're going to then go from left to right. And I know that first thing that we're going to be doing is the exponents. So this is going to be 3, and this is going to be, right, we're bringing this down right here. And then we've got 3 times 3. And so 3 times 3 is going to give us what? Positive 9. And then what we can do is we can bring down this 3. And then we've also got the minus 4, and then times the absolute value of 3 plus 6. So there's a lot going on here. So what I'm going to do now is we've got to do some multiplication. 3, if we're looking right here, 3 times 9 is going to give us 27 minus, or we'll do negative 4. Times, and this is the absolute value of 3, but the absolute value is the distance from 0, so the absolute value of negative 3 is also 3, so 3 times negative 4 is going to give us negative 12, plus 6. So now we've got to do just a little bit of addition and subtraction. We can go from left to right. And so 27 minus 12 is going to give us 15. And then when we add 6, 15 plus 6 is 21. So 21 is our answer. And let's see if that is an option. Is 21 an option? It sure is. It is option number 3. 3 is the correct answer for number 12. Let's take a look at number 14. It says when 6x squared minus 4x plus 3 is subtracted from, and then we've got this trinomial right here, the result is what? So if it's subtracted from this, we're going to be starting with this. So I'm going to write this first. Alright, I'm going to do 3x squared minus 2x plus 3. And we're going to be combining like terms. And I know that when we're looking at this, if we're subtracting, what we're going to have to do is we're going to be changing all of these signs. So this positive 6 becomes a negative 6. This negative 4 becomes a positive 4, and this positive 3 becomes a negative 3. And so I'm going to rewrite that as, instead of 6x squared, negative 6x squared, positive 4x, and then negative 3. And when we do that, we have to now combine like terms. So let's take a look at this. It's 3x squared. We're going to be combining this, right? Like terms, because the x squares are the same. So 3 minus 6 is going to give us, of course, negative 3x squared. And now we're going to look at this. Negative 2x plus 4x is what? Plus 2x. And then we've got 3 minus 3, and that's going to give us 0. So the correct answer is negative 3x squared plus 2x. Let's see if that's an option. And it sure is. It took me a second to find it there with all these things going on. It is option number 2, negative 3x squared plus 2x. This is our answer. Let's take a look at question number 16. It says, which equation represents a line that is parallel to the y-axis? So if we've got our coordinate plane, we know that this is the y-axis, right? It goes up and down. So we want to know which one would be parallel, which one is going to be going up and down, right? So let's take a look at this. We've got x equals 5, x equals 5y, y equals 5, and y equals 5x. So what we can do right off the bat is eliminate these ones with multiple variables, because we want one that's parallel. And so that means that it's either option 1 or option 3. So we want it to be parallel to the y-axis. If we did option number 3, that means we would be counting up 5, 1, 2, 3, 4, 5, and then we'd be drawing a line. And that would not be parallel to the y-axis. That would be parallel to the x-axis, because that would be a horizontal line. We want a vertical line. So when we look at option number 1, x equals 5, I'm going to count over 5, 1, 2, 3, 4, 5, and then I'm going to be drawing a line just like that, and this one certainly is parallel. It's going up and down, so the answer is option 1. Let's take a look at question number 25. It says, which value of x is the solution to the equation? And then here you've got it right here. We would need to figure out what x is equal to. So the first thing that we're going to do is distribute, because we see the parentheses, and so this is going to be 2x, 2 times x is 2x, and then 2 times negative 4 is going to give us negative 8, plus 7 equals 3, and so now we can combine like terms. I can see that we can combine these, so this is going to be 2x minus 1 equals 3, and then we're going to need to take this and bring this over to this side. We're going to add 1 to both sides, and when we do, the 1's cancel out, and we're left with 2x equals 3 plus 1 is 4. We now need to apply the inverse operation. We're going to divide both sides by 2. We can cancel these out, and 4 divided by 2 is simply 2. 2, x equals 2. 2 is our answer. Let's see if that's an option. Wow, it is. Nice. It is option number 2. All right, ladies and gentlemen, good luck on the final Algebra Regents.